Greetings, AP Calculus AP students. Mr. Record here. Going to take a look at example 1, part B from topic 5.5. We're all about using the candidates test. If you joined us for part A of the video, we briefly walked through the guidelines for finding the relative extrema. It's very important that it all begins with taking the derivative and finding the critical numbers. That's step 1. Then you evaluate each of those critical numbers in your original function, mind you, not the derivative. And then the key step number 3, evaluate each endpoint as well. And then once you set that up in a nice organized table, the smallest f value is the absolute min and the greatest one is the absolute max. It's pretty easy. If you practice it, you'll get really good at this. And as I said before, it's an extremely important part of the AP exam. So let's take a look at our example B. Find the extrema of f of x equal 2x minus 3x to the 2/3 on the closed interval -1, 3. So we're going to start with our derivative. F prime of x is 2 minus, okay, now here 3 times 2/3, that would be 6/3, which is going to leave us with a 2. X, and then when we take 1 away from that exponent, a little tricky, 2/3 minus 1 is equal to -1/3. Now, I would much prefer to rewrite my derivative as a single clean fraction. And I can start the process by dropping that x to the 1/3 below the 2. Now be careful, you don't want to drop it below both of these. That's not the case, because if you do that, you're going to trick yourself into thinking that this might be equivalent to 0, and it's certainly not. Drop it only below the second 2, and then I can get a common denominator, and that denominator would certainly be an x to the 1/3 if I multiply this 2 by x to the 1/3 over x to the 1/3. And so I might have something like this. And then at that point, it's really up to you, but you could rewrite these 1/3 exponents as cubed roots because maybe we relate to them a little bit better. I'm going to let you make the decision there. All that really matters is that you can pull off the algebra to find the critical numbers. And the critical numbers are going to occur when the derivative is equal to 0 or when the derivative is undefined. All right, well, let's take a look at when this derivative is 0. So we're going to take 2 times the cubed root of x minus 2, and we're going to solve this. So let's add 2 over, and at the same time, let's divide by 2. Hopefully you guys can pull off both of those steps at once. When we cube both sides, lo and behold, we get a critical number of x equal 1. Note that that x equal 1 is indeed on this interval, so we're going to definitely keep it. We're going to use it in our table of values. And then as far as our derivative being undefined, the cubed root of x is 0 whenever x is 0. And once again, that is a value on our interval, so we're going to use him as well. I want to highlight this f of x so that we don't forget that he is our function that we want to plug things in for when we build our table. And you'll start to see how similar this looks to the previous problem. That's what I meant. If you guys really practice this, not only are you going to get good at it, and this is why you want to practice, this is why you want to work on the skill builders that I make for you, is it helps you understand the calculus for sure, but it develops the ability to be efficient at it so that you can move through problems a little quicker and not run out of times on quizzes and tests. And maybe you can have this extra time so that you can check over your work. It's really important to become efficient. So we are going to check values in no particular order. I'll just go numerically here, -1, 0, 1, and 3. And we are going to plug those into the original function. So we have 2 times -1 plus 3. And I tell you what, for this x to the 2/3, I think what I'm going to do is call that 3, the root, and the power will be the 2, and that might make it a little bit easier for us to interpret this. So what we have here is -2, of course, and then this -1 will be squared, becoming a +1. When we cube root that, we're going to get +1. 3 times 1 is 3. So no arguments here. We're going to get 1. If we do the same thing for 0, 2 times 0 plus 3 times the cubed root of 0 squared. Well, that seemed to be a waste of time because this entire term is going to wipe out and become a 0 as well. And so we have a 0. So far we have a max and a min, but let's see if that changes. I'm sure it will. 2 times 1 now, minus 3 times the cube root of positive 1 squared. And so this would be 2 minus 3, which is negative 1. So it looks like we have a new minimum in town. And then we're going to check 3. 3 is tricky. Take a look at what we've got here. 2 times 3 minus 3 times the cubed root of 3 squared. All right, this one's got me a little worried. This is going to be 6 minus 3 times the cubed root of 9. And let's say that this is a no calculator problem. I know it says you can use your calculator to verify, but that would be after the fact. This could potentially be a no calculator question. I think we could probably figure this out. If we know that the cube root of 9 is pretty close to the cubed root of 8, it's a little bit bigger than the cubed root of 8, which means that this is a little bit bigger than 2. Okay, well, if that's the case, then I'm taking 6 minus something that's a little bit bigger than 6. But it's not a whole lot bigger than 6. In fact, I don't think that we can probably reason that it's so bigger than 6 that it's equivalent to 7, perhaps. So we know that this is probably something that's close to 0, but yet negative. Now, the reason why that's going to be interesting is because we're going to have to be able to compare that to this negative 1. Now, I think it's pretty clear that our absolute max is going to be 1. That was the only positive number that came through. But the question is the absolute minimum negative 1? Well, I'll tell you what, let's go ahead and look at the graph and get a little bit more insight here. If we take a peek at this graph, yes, here is our minimum. Oops. Looks like I may have made a mistake. Let's go back and look at this. If I was to plug in negative 1 for this, I did not do a very good job of realizing that there's a negative sign built into my problem. And maybe you guys saw that and were thinking, oh no, stop the video. Not a big deal, guys. We can go ahead and make that change. So it turns out that this problem is going to be a little bit easier to deal with. And here's why. Because there was a minus here, I have negative 2 minus 3, which is, of course, negative 5. Now, luckily, I didn't make any egregious mistake here because a minus to the plus is still going to be 0. I used the correct sign here. Now, it's very easy to see that, yes, this is something that's probably going to be negative and very close to 0, but what difference does it make at this stage? Because negative 5 is going to be the overall smallest value. And so I'm going to go ahead and write that in now. But I need to erase this absolute maximum because I see that 0 is the highest overall value that I actually have here. So according to my table now, I think I have the correct information. Okay, let's double check. Is the graph going to depict the max at 0 and the min of being negative 5? Here's the max at 0 or equal to 0, and the min is negative 5. And remember what we said was happening here at positive 3? We were going to get a y value that was pretty close to 0, but yet still negative, which doesn't make it high enough to counterbalance that 0 there. All right, so hopefully that makes sense here. Sorry if I kind of led you astray with a couple of mistakes, but it shows you that it's very easy to make mistakes if you're not focused. Hey, maybe I did that on purpose. Who knows? Anyhow, hope you enjoy this. We got one more problem to look at. It's going to be this part C. It's a trigonometric question. I really invite you to spend some time maybe taking a look at this, 2 sine of x minus cosine of 2x on 0 to 2 pi, practice it, and then join the video and see if your findings are correct. Thanks for joining. We'll see you next time.